Liebe GFM-Mitglieder, liebe Webinargäste, herzlich willkommen. Heute ist das Thema die Optimierung von KI-gestützten Entscheidungen. Unsere Referentin, sie spricht von Worker-Centric AI. Also wir wissen alle, die künstliche Intelligenz hilft uns bei unserer Produktivität, beim Arbeitsablauf. Aber heute geht es tiefer. Auch wird die künstliche Intelligenz Einfluss haben auf unsere Werte, die Werte der Beschäftigten in einem Unternehmen. Wird die künstliche Intelligenz Einfluss haben auf die Dynamik am Arbeitsplatz? Und es freut mich sehr, dass wir eine absolute Spezialistin, Expertin hier bei uns haben im Webinar, Sana Bucinka. Sie wird ihren Namen dann noch richtig aussprechen. Sie promovierte in Informatik in Harvard und wo sie sich seit Jahren mit der Schnittstelle, zwischen Mensch und KI beschäftigt. Im Moment erreichen wir sie gerade in Amerika, wo sie für Microsoft arbeitet, und später im Herbst dieses Jahr wird sie dann Assistenzprofessorin beim MIT. Und jetzt lese ich noch ein paar Auszeichnungen vor, die sind wirklich unglaublich. Ihre Arbeit wurde mit dem IBM PhD Fellowship ausgezeichnet. Die University of Michigan nennt sie The Rising Star in AI. Stanford sagt Rising Star in Management Science and Engineering. Und vom Kosovo, wo sie herkommt, dort wird sie unter den Top 10 Most Inspiring Women geehrt. Und jetzt wechsle ich auf Englisch, damit auch Sana versteht, wofür wir reden. Sana, we are delighted to have you with us today, and we are anxious to find out what you're going to tell us today about worker-centric AI and how AI will somehow shape or optimize our decision-making. Welcome. Thanks for being here.
Thank you for the invite, and hello, everyone. My name is Ana Bucinta. I'm a postdoctoral researcher at Microsoft, and I will soon be joining MIT Sloan and computer science as an assistant professor. So maybe because this is some of the audience will find this important because my appointment is also in a business school. So I frame my research as value-aligned human and AI interaction because I study human and AI interaction in the context of work. So what I mean by value-aligned human and AI interaction is that as we interact with AIs in the context of work, we have to amplify work and workplace values. So what that means is, yes, work quality and productivity, but also human-centered aspects of work, such as workers' skills in the tasks that they use AI for, their agency, their creativity, collaboration with others, as well as work meaning. So about my own work, so at the conceptual level, I challenge the implicit assumptions and principles that have hindered progress in human and AI decision-making. I also contribute novel principles and interaction techniques for effective human and AI interaction. At the organizational level, I explicitly account for worker and organizational values in human and AI interaction design, which is typically not done by human and AI interaction researchers, whereas work in organization psychologists, for example, don't have the technical training to shape the technology towards the worker. As well as I provide a worker and workplace-centric vision for the role of AI in the workplace. So just as the Industrial Revolution shaped manual labor, AI is revolutionizing cognitive work with more than 65%, and this, of course, is changing a lot in different countries, have different uptake of AI systems, but more than 65% of workers, according to a McKinsey survey, use AI in their work. And this has exploded, especially with the advent of LLMs or the commercializations of LLMs such as ChatGPT. So while there is potential for AI to augment work, essentially This is a vision of human and AI co-creation and human and AI intellect, essentially, in which intelligence augments human cognition. We still are not there. In reality, what we get is essentially people over-rely on the AI. They accept wrong AI suggestions when they can make better choices on their own. There is no human and AI complementarity where we don't get the strengths of both the humans and the AIs. And there's also this risk of deskilling where workers lose the very skills that they are supported by the AI for. So my vision is to design AI systems that are worker-centric or pro-worker, that complement people in their roles, enhance productivity and work quality while amplifying values that make work meaningful to people. But why do we need AI systems that complement and augment workers? So from the standpoint of labor economics, technologies that complement human expertise and upskill workers generate sustained economic benefits and enable shared prosperity, whereas those that displace workers without alternatives erode job security, suppress wages, and exacerbate economic inequality. And from the standpoint of work design, so like going one level deeper, essentially is that 40% of the workers globally say that they might leave their jobs in the near future. And this is mainly because they see a lack of career development and advancements in their jobs. They lack meaningful work, lack workplace flexibility, and all of these are exacerbated by the way that we're designing and deploying AI systems in the workplace. So with my research, I ask, how will AI assistance affect what we value about our work? Existing tools and research in human and AI decision-making typically focus on how can AI optimize decision makers' accuracy or efficiency. But I argue that as these tools become integrated in our workplace and workflows, they affect values beyond the output that we produce with AI. They affect the skills that we use the AIs for, our agency in the tasks where an AI is carrying out tasks for us, as well as task meaning where we're splitting the task in half with an AI system, but more so also collaboration with others when we turn to these tools rather than colleagues for questions. So I ask, how can we optimize decision makers' values, both human-centric and also output-centric values of work? And I frame this research as value-aligned human and AI interaction because I believe this is an interaction problem. So different from value alignment research in AI, which focuses on aligning AI outputs with societal values, such as AI should uphold fairness or privacy. I care about downstream values that emerge from a human interacting with these AI systems. And the superpower, essentially, what I was trained for is in interaction itself. So I intervene at the interaction design. And what I mean by that is that instead of focusing only on the model layer, on this, like making this AI system better and better, I also see interaction itself as a leverage point for intervention. So what I mean by that is that I optimize the human and AI interaction by framing it as an optimization problem. So for example, if we think about values as something to optimize. So essentially, when I break this down in three questions, such as what do we optimize? We optimize the values of work. We have to represent this problem. Essentially, we have to represent the human and AI dyad in a sense that we can further optimize it. We have to intervene in this system, and then we have to determine when it is the optimal time to intervene in this human and AI interaction. So I will talk about three different projects essentially during this talk, where where I will focus in each of these kind of sub aspects of optimizing human and AI interaction. Okay, so let's focus first on optimizing human and AI accuracy as the more kind of the most important aspect that we care about in human and AI interaction. I just want to give you an illustration of the type of decision-making tasks that we had in mind as we were designing these experiments back 5 or 6 years ago. So, for example, you can think about the current design of AI assistants. A doctor is given a decision instance about a patient, such as patient symptoms, and then they are given an AI recommendation around what treatment to provide to this patient, as well as an explanation as to why the AI made this decision. So this explanation can be like a feature-based explanation highlighting which symptoms led to the AI make a certain decision, but it can also be a natural language explanation, such as an LLM giving an explanation and so on. So we call this simple explainable AI because the AI is essentially providing a reasoning about its thought. And as explainability and interpretability researchers, we were super excited because we thought that, like we're going to get this human and AI teams that perform better than humans alone or AIs alone, because the humans can see the inner workings of the AI. But in reality, this is not what happened. What we saw was that there was no human and AI team complementarity. When humans and AIs work together, they typically perform better than humans alone, but worse than AI alone. And in a study, we looked at this deeper and we saw that this typically happens because people over-rely on the AI. So essentially, when the AI provides a wrong suggestion, even if they can make a better choice independently, they tend to go with what the AI has said. So essentially, the team performance when the AI is incorrect is even worse than human alone. And in a study, we asked deeper, but why do people over-rely on the AI? And we tackled this question through the lens of dual process theory of cognition. For those of you that may not have heard about this theory, this is a seminal theory in cognitive science, in cognitive psychology, where essentially it states that people typically have dual processes of processing information. This can either be system one thinking or system two thinking, where system one thinking is fast and heuristic, such as, maybe the route you take to work every day is, you don't think about it very deeply, you just turn the automatic mode, whereas system two thinking is slow and slow and analytical, but it's also effortful. So based on this theory, we hypothesized that people develop heuristics of whether and when to rely on AI suggestions, so more like a system one thinking. Whereas evaluating AI suggestions and explanations required cognitive effort that people were unlikely to exert. And we hypothesized that if we can induce people to engage in more analytical thinking when they process AI recommendations and explanations, their over-reliance will decrease. But how can we push people to think more? How can we push people to engage more in analytical thinking? So we introduced cognitive forcing functions, which allowed people to form an initial hypothesis about a decision before seeing the AI assistance. For example, people had to make a choice on their own first, and then they would see the AI suggestion and could update their decision, or they had to wait for a certain amount of seconds before seeing the AI suggestion, or they had to click on a box to see what the AI had to say. And we ran an experiment, and indeed we saw that people that performed this task with cognitive forcing functions significantly reduced their over-reliance compared to those that performed the same task with simple explainable AI solutions that just gave the answer right away. But this came at a cost. So essentially, people hated these interventions. People did not like to be pushed to engage more in analytical thinking. And we still do not have this human and AI complementarity. So we still do not have this holy grail of human and AI interaction research. And what I just showed essentially was that we reduced over-reliance with interaction design. So we did not improve the model, we improved the interaction, and we improved an outcome of human and AI decision-making. So essentially how we did that was that we came up with this design of intervening in human and AI decision-making with cognitive forcing functions, which helped individuals to reduce their over-reliance. But this work also revealed something fundamental about human and AI decision-making, precisely is that previously most of the implicit assumptions in the field were that people cognitively engage with each AI recommendation and explanation, whereas our work showed that cognitive engagement moderates human and AI performance in decision-making. So essentially, we revealed something fundamental about our understanding of what matters in human and AI interaction and how do we represent the human and AI dyad, and that is cognitive engagement. Beyond our work, like multiple studies have introduced other interaction techniques now that tend to push people to engage more in analytical thinking, such as explanations without decision recommendations, where the AI just provides an explanation in the settings but does not give the solution. Evaluative AI that asks the human to make a decision and just critiques their decision without giving an opinion on its own. And explanations framed as questions, where the explanation, rather than stated as a statement, it is essentially engaging the individual more by being framed as a question. So to show you like a flavor of what these kind of interaction techniques look like, let's think about an exercise prescription task, which is somewhat analogous to let's say treatment prescription. So for example, for an exercise prescription task where Daniel wants to increase flexibility and lose weight, he is 31 years old and works as a cook. His current engagement in physical activity is low. He is obese. He enjoys individual and indoor activity. He also has access to a gym. So which one of these would be a better choice for Daniel? And an AI recommendation and explanation, or like this simple explainable AI, would look as like follows, where the AI would tell you what the right answer is, and it will also give you a reason to explain essentially its suggestion. Or an explanation-only interaction technique would just show some information about one of the choices without revealing which of the choices is the better one. Whereas an AI support on demand would ask the human to click on a button, for example, to see this AI suggestion. So growing evidence shows that different contexts may require different interaction techniques. So essentially what types of interactions we show to the humans depends on whether the AI is certain versus uncertain, whereas different individuals may require different interaction techniques. Specifically, we saw in our research that there's this concept in cognitive psychology called need for cognition, which captures how motivated are people to engage in analytical thinking. And it's a construct essentially that is measured through a questionnaire where people respond to Likert scale questions around I enjoy engaging in effortful thinking, or after thinking I don't want to be essentially introduced with more difficult problems and so on. So it's essentially a motivation questionnaire around how much people enjoy thinking. And this is what we saw in previous research that captures some of the performance gaps between different groups while interacting with AI. Also, different objectives may require different interaction techniques. For example, if we want the job to just get done, you can just give the full support and the human will rely on the support. But if we also care about the human to learn something about the task, then you may show some partial form of support that will elicit more engagement on the human side. But how do we decide which kind of interaction technique is best for whom and when? So to answer this question, in another paper, we framed human and AI interaction as a reinforcement learning problem. So what I mean by that is that we just like a very brief a very brief illustration of what reinforcement learning is for people who may not have heard of it. It's a machine learning technique to come up with policies of how to act on an environment to optimize some reward from that environment. For example, you can think in games and so on. It's a very good paradigm to think about reinforcement learning, where there is some state. The RL agent observes the state of the environment, and based on the state, it takes an action, and based on this action, essentially, it gets a reward from the environment. So what we did was that we framed the human and AI decision-making essentially as the environment, where there's like this human, this AI system that is designed for this task, and they are making these decisions. So the reward is to optimize the interaction objective. This can be the decision accuracy as a proximal reward, but you can think also of a sparser and more distal reward, such as human learning, which can be captured at a less granular level. Whereas the state, it's a representation of human and AI dyad. For example, how certain is this AI that is assisting the human on this task? How motivated is this person to think? How skilled they are in this specific task, and how skilled they are in this specific question. And the concept in question, this can be like this type of patients, like how many of such patients has this doctor, for example, correctly diagnosed in their work. And the action space is the interaction technique. So essentially, we can either show full support, this AI recommendation and explanation, we can show explanation only, AI support on demand, or maybe withhold AI assistance. So we followed an offline reinforcement learning approach where we ran a data collection study with an exploratory policy where people interacted with essentially completed this exercise prescription tasks, a series of such exercise prescription tasks, and they were randomly shown one of the interaction techniques like explanation only or recommendation explanation, on demand, or no AI. So this was like uniformly sampled from the action space. Then we learned the optimal policy, and we ran an evaluation study with the optimal policies. But before that, let's see what did we learn? Essentially, we learned these policies of like what type of support to show to the human at what time. So let's see what the policies showed. So what this graph is showing is the y-axis is the percent of states in which an action was selected. And the x-axis is the type of interaction technique. So for example, what we see here is that when the AI is certain, the policy has learned to either show the human an AI recommendation and explanation, or to show an explanation only. So essentially to show some form of AI support. Whereas when the AI is uncertain about a decision, the policy has learned that the human over relies on it, so it withholds the AI assistance. So this is great and it makes sense. But this happened only for people high in need for cognition or people that are motivated to think. So what happened for people low in need for cognition is when the AI is certain, we learned the similar policy, but when the AI was uncertain, we learned the policy had learned to either show no AI or show AI on demand. And to me, that did not make sense because, like if the AI is wrong, just don't show any AI at all. So I went into the data and just looked more deeply on it. And what I found was that people that were not motivated to think would not even click on a box to see what the AI had to say. So essentially, they just wanted to get done with the task and proceeded. So the policy learned that people low in NFC would not seek more info. And this is very interesting because we discovered something about how people interact with AI systems by interpreting what the policy has learned. So now we ran an evaluation study with these like optimal policies that I just showed you. So what the takeaway essentially was that the y-axis is the type of policy that people interacted with, and the accuracy policy is the policy that was optimized to optimize essentially accuracy of human and AI decision making. And what we achieved here was this like human AI complementarity, where humans and AIs together perform better than humans alone or AIs alone. And this is like awesome because we rarely see this research we rarely see this result in human and AI interaction research. Okay, so what's more is that people actually enjoyed interacting with these policies because they did not push people to engage in every single instance. They selectively pushed people to engage more only in situations where their input would be most valuable. Okay, so here I showed you that we achieved human and AI complementarity by intervening on the interaction design as well. So we did not make this task layer AI better or like model layer AI better. We optimized the interaction, and this improved human and AI outcomes. And how we did this was that we modeled essentially the human and AI decision making to determine when to intervene with what type of intervention. So going to the human-centric aspect of this human and AI outcomes, let's focus first on improving human decision-making skills in AI-assisted decision-making. But why do we care about this to begin with? While it is conceptually distinct from AI's decision-making, evidence from automation and aviation is important to consider when we think about the risks of descaling from assistance. So in aviation, 80% of accidents are due at least in part to human error. So this happens because pilots train to fly planes, but their job becomes overseeing a machine where, on average, a pilot flies a train by themselves only 4 minutes per flight. And they get deskilled in the job. It means that they become less capable of taking over from the machine as years go by. So going to the AI-assisted decision-making, current evidence shows that AI support can impede skill improvement. So for example, when people do a task with an AI support, they typically don't get better at it. But what's worse is that a study from real-world setting showed that endoscopists were actually deskilled after being exposed with an AI system for 3 months in practice. So essentially, they lost the diagnostic skills that they had. Not all of them, obviously, but their skills decreased. So we asked, like, can we design AI systems that not only improves accuracy, but also enhances the skills of decision makers? So as we improve, for example, if we use ChatGPT for coding, can we actually get better at coding as well, not only just code more? So what our insight was that most current AI explanations do not address knowledge gaps directly. For example, to exemplify, let's consider this exercise prescription task, again, like another exercise prescription. So Natalie wants to build muscles and increase flexibility. She is 62 years old and is retired. Her current engagement in physical activity is low. She is not overweight. She enjoys group and indoor activities. So which one of these exercises would best suit Natalie? So the typical AI explanation essentially gives an AI recommendation and an explanation of a laundry list of reasons why the AI made a certain choice. I argue that this is not the optimal aspect of giving human explanations, because people seek contrastive explanations. This is what social science research shows, is that people seek these explanations that explain why P rather than Q. So essentially, why something that happened rather than some other alternative. So in this instance, our human would be, for example, confused because they would have chosen resistance training, whereas the AI chose Pilates, but there is no explanation why resistance training is not a good choice. So a contrastive explanation in this setting would look like this, where many people would choose resistance training, but the AI suggests Pilates because Pilates supports the flexibility goal better than resistance training. And to look at the anatomy of the contrastive explanations, it first acknowledges the dimensions that make the human choice a plausible option. So here, for example, resistance training is better for muscle building. And then it contrasts the AI and the human choice along the dimension in which the AI choice is superior, in this case, the flexibility goal. Also connects the characteristics of the AI's proposed exercise to a benefit relevant to the decision instance. In this case, for Natalie, essentially aims to both build the muscles and enhance the flexibility, which resistance training does not support. So now probably our human is satisfied with the explanation. So we frame these contrasting explanations as more human-centric because previous work essentially considered contrastive explanations more in AI-centric, or the foil is inputted, meaning that why the AI's top choice rather than the AI's second best choice, or why the AI's choice rather than some inputted response from the human. So they first asked the human to input the choice and then showed the contrastive explanations. Whereas what we do is that we have this like predicted foil where we say why AI's choice rather than a typical human choice for the same task. So how did we design these contrastive explanations? It's that we built a human model for the task. So we allowed humans to make decisions about these exercises unassisted, and then we trained a model of like what a typical human would say for an instance. And we also had an AI model which was trained on expert labels of kinesiology. And we contrasted these two choices via a contrast module, which was then fed into an LLM. This scaffold was fed into an LLM essentially to generate these in natural language. So essentially the predictions were from these like predictive AI systems, whereas the generations were from the LLM. And we came essentially to these contrastive explanations that I explained. So we ran an experiment where individuals were asked to make decisions first without any AI. Then they were randomized into a condition, and then we removed the AI system to see how much they have improved after interacting with the AI. So the conditions were no AI. unilateral explanation. This is the typical AI explanations that just shows the output from the AI side, and the explanation explaining essentially AI's reasoning. A contrastive explanation with a predicted foil. This is our intervention where this many people's choice essentially is coming from a predicted model of human decision making. And our results essentially showed that people learned, so the x-axis is accuracy and the y-axis is learning or skill improvement post-intervention. So what we see is that people improved their learning significantly more with contrastive explanations that predicted their common misconceptions compared to unilateral explanations, which is the status quo of providing AI explanations without hurting their accuracy. So this was also significant and a medium-sized effect. So what we, in addition, asked essentially here was, okay, so contrastive explanations seem to work, but what aspect of contrastive explanations is making this successful? So we added two additional conditions, contrastive with inputted foil, where we asked people to select one of the drop-down exercises, and then we contrasted that input to the AI's choice, or contrastive with a random foil, where instead of this foil coming from our predictive model, we just randomly selected one of the exercises and contrasted that with the AI's choice. So what we learned was that the quality of foil matters for objective outcomes. So meaning that predicted foil led to more learning than random foil. So just randomly comparing an exercise to the AI's choice did not improve actually people's learning as much. And timing matters for subjective experience. So inputting the foil diminished the subjective experience of the interaction. So this is congruent with our finding from cognitive forcing functions, where people did not like to make their own decisions before seeing an AI choice. So when we asked them to input the foil, essentially we diminish the subjective experience of interaction. So again, here I showed you that we enhanced user skills with interaction design. Specifically at the interaction layer, we have an additional model that extracts important information out of this, like the AI model, and presents that to the user in a way that improves both their learning along with accuracy. And how we did this is that we intervened, we designed a new intervention of human and AI interactions, specifically contrastive explanations. So with that, I showed you that we can account for values of humans in human and AI interaction, and how we design the interaction matters for what outputs we get from AI assistants. Again, these findings were mostly from predictive AI models, but a lot of what I just shared essentially generalizes with generative AI systems as well, which the conceptual findings here are essentially generalizable there as well. Okay, I also thank all of my collaborators, my advisor Krzysztof Gajos at Harvard, with whom I've done most of this research, as well as the other collaborators for different projects. Thank you.
Zena, thank you very much. This was highly interesting, amazing stuff. Tell me in the short term, what is your recommendation for us? Most of us are using AI, knowing it's not, the machine is not perfect. Our way of using it is not yet optimal. But I guess we will, it's such a cool technology. We will keep using it. Give us some recommendation. Where should we put the emphasis? What should we look out for?
Yeah, I think that obviously AI is extremely useful. In terms of like professional practice, maybe I should stop sharing my screen here. In terms of professional practice, I would advise people to identify the tasks for which they own professional ownership. So, for example, for a researcher, if it's idea generation, if it's an aspect of your work that you hold dear and gives you meaning, I would be super careful to when using AI for that, because you can get these skills, and we're getting these new empirical evidence from generative AI and in the workplaces that it is hurting people's skills and it is hurting people's self-efficacy. So I argue that human expertise is something that should be elevated with these systems. So if you're seeing this negative usage, the negative outcomes from your usage of AI system, be careful of how you use it. Instead of using it for answers, use it for critiques. Use it for conversation, but not for direct work done. But for tasks that you find repetitive, that do not hold a lot of value in your work, but can be verified, and this is an important caveat. I think that that's great. It's a great usage of AI systems. If you can verify the output like very quickly, oh, okay, so this is a design that I like of a website, and I was like very quickly able to code this with Cloud Code, then that's a great usage. But then if you cannot verify, if you're hurting the code bases of your whole company and so on, I would be careful.
Great, yeah, understood. I think you blew our minds. The audience is very quiet. Hang on, there's one comment coming up. Let me just have a look. No, nothing yet. But anyway, thank you very much for having taken the time to engage with us. This was super, super interesting. And well, all the best also with your young family. And thank you very much, Zena.
Thank you. Bye-bye.